Hello everyone, and thank you for watching my video today on the binomial theorem. So we had done some work already on the binomial theorem, but now we're going to officially learn it and how it can be used. Before we do that, let's talk about Pascal's triangle, which we talked about in class recently. So remember Pascal's triangle, we want to add the next row to this. It's going to be 1s on the outsides, and then add the 1 plus 2, add the 2 plus 1. And that's the next row. Remember, this would be n equals 0, n equals 1, n equals 2, n equals 3. So that's a binomial cubed. For a binomial to the fourth, 1's on the outside, and then 4, 6, 4. And next row, n to the fifth. So n equals 5, so that would be 5, 10, 10, 5. And we can keep going with that forever. But that could be a pain having to draw that out every time you want to expand a binomial. There must be a better way. That's what we'll get to soon today. All right, using Pascal's triangle and the patterns from yesterday, expand each of the following. So x plus 2 to the third. So to the third power, our coefficients are 1, 3, 3, 1. So 1 plus 3 plus 3 plus 1. All right, that's going to be x to the third, x to the second, x to the first, x to the 0. And then times 2 to the 0, times 2 to the first, times 2 squared, and times 2 to the third. Simplifying that, we're going to get x cubed plus 6x squared plus 12x plus 8 x to the 0, or just 8. All right, to the fourth power, so that'll be our next row, 1, 4, 6, 4, 1. All right, so we got 1, 4, 6, 4, 1. And that's going to be 2x to the fourth, 2x to the third, 2x to the second, 2x to the first, and then 2x to the 0. I'm not going to write it. Negative 3 to the 0, negative 3 to the first, negative 3 to the second, negative 3 to the third, negative 3 to the fourth. So simplifying this, we would get 16x to the fourth. And let's see, 4 times 8 times 3 is 96, so minus 96x cubed. 6 times 4 times 9 would be 24 times 9. 25 times 9 is 175, minus 9 is 166. So it'd be 166x squared. 4 times 2 times 27. So 27 times 4 would be 108, times 2 is 216, so minus 216x. And then 3 to the fourth would be 81, so it would be plus 81. And that would be our expanded binomial. Okay, letter C, so this is the fifth power, so our coefficients are 1, 5, 10, 10, 5, 1. So 1 plus 5 plus 10 plus 10 plus 5 plus 1. X to the fifth, x to the fourth, x to the third, x squared, x to the first, and x to the 0. Negative 2y to the 0, so that's nothing. Negative 2y to the first, negative 2y to the second, negative 2y to the third, negative 2y to the fourth, negative 2y to the fifth. All right, so it's going to be x to the fifth. In the interest of time, I pulled out my calculator to help us if we need it. But negative 10 x to the fourth y. The next one is 40, so plus 40 x to the third y squared. And then 80, so minus 80 x squared y to the third. All right, and then 16 times 5 would also be 80, so plus 80xy to the fourth, and then minus 32y to the fifth. And that would be our expanded binomial. All right, last one's fourth again, so 1, 4, 6, 4, 1. And that'd be x squared to the fourth, x squared to the third, x squared to the second, x squared to the first, and then x squared to the 0. 4 to the 0, 4 to the first, 4 to the second, 4 to the third, and 4 to the fourth. So it'd be 1x to the 8th plus 16x to the 6th plus 96x to the 4th. All right, let's see, 64 times 4 would be 256 x squared. And then 4 to the 4th is also 256. So that would be our expanded binomial there. Okay, number 2, so let's find the third term of a minus 3b to the 6th. All right, well, if I was doing this to the 6th power, the third term, 1, 2, 3, so my coefficient is 15. It would be a going down 6, 5, 4, so a to the 4th, and negative 3b going up 0, 1, 2, so negative 3b squared. So I would get 15 times 9, which is 135, a to the 4th, b to the 2nd. Okay, without using the entire Pascal's triangle, for each one we can use NCR, n choose r, okay, a combination formula here, which is n factorial over n minus r factorial times r factorial. All right, so to practice this, let's use the formula to evaluate each of these. So for the first one, it's 6 choose 3. That's how we would read that, 6 choose 3. 6 factorial over 6 minus 3 factorial times 3 factorial, which is going to be 6 times 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1 over 3 times 2 times 1. So if we shorten that up a little bit, I'll show you what I'm talking about here. Basically, those cancel. So we're left with 6 times 5 times 4, which is 120, or 3 times 2 times 1, which is 6. So that'd be 60 over 3, which is 20. Second one, 5 choose 1. So it's 5 factorial over 1 factorial, 4 factorial. So 5 factorial over 4 factorial is just going to be 5, and then 1 factorial, which is 1. So this is just going to be 5. 7 choose 4. So it's 7 factorial over 4 factorial, 3 factorial. We can switch those around if you need to. So it's going to end up being 7 times 6 times 5 over 3 times 2 times 1, which is 35. And finally, 10 choose 6. So 10 factorial over 6 factorial, 4 factorial. And remember, those two can be switched there. So it's going to be 10 times 9 times 8 times 7. The rest cancels out with the 6 factorial over 4 times 3 times 2 times 1. So 10 times 9 times 8 times 7 divided by 24. We get 210. But if we had a calculator, we can do this even easier. So if you have a graphing calculator, go ahead and get that out right now. And let's do the last one, 10 choose 6. What you're going to do is you're going to type in 10, and hit math, scroll over to probability, and number 3 is n choose r. Actually, this one's a little bit different. You can just hit the n choose r, and then you put the 10 in after that. And then the 6. And look, you get 210, just like we thought. If you have the older calc, you got to type the 10 in first, then hit NCR, and then hit 6 after that. So we're going to keep our calculator out for the rest of this here to help us. So number 4 says, use the above formula to compute the binomial coefficients. Find the first 3 terms of x plus y to the 9th. All right, so that's going to be 9 choose 0, x to the 9th, y to the 0, plus 9 choose 1, x to the 8th, y to the 1st, plus 9 choose 2, x to the 7th, y to the 2nd. Notice how these numbers are always matching. All right, so 9 choose 0. is 1, which makes sense. How many ways are there to choose 0? There's 1. Just don't choose any. So it'll be x to the 9th. All right. Now, I choose 1. It would be 9, x to the 8th y. Nine choose 2 would be 36. And there's our first 3 terms. Okay, from the first 3 terms of x minus y to the 25th. So that's going to be 25 choose 0, x to the 25th, negative y to the 0, plus 25 choose 1, x to the 24th, negative y to the 1st, plus 25 choose 2, x to the 23rd, negative y to the 2nd. All right, so 25 choose 0, that's 1, so it's just going to be x to the 25th. 25 choose 1, that's 25. But it's negative y, so it's going to be minus 25. X to the 24th y. 25 choose 2. Let's use our formula to find that. So I'm just going to go off to the side over here. 25 choose 2 will be 25 factorial over 23 factorial 2 factorial. It's going to be 25 times 24 over 2, or just 25 times 12, which is 300. So that's going to be plus 300 x to the 23rd y squared. The negative y squared would be positive y squared. There's the first 3 terms of that. All right, letter C. So we have 15 choose 0 of x to the 15th times 2 to the 0 plus 15 choose 1 x to the 14th times 2 plus 15 choose 2 x to the 13th times 2 squared. So that's just going to be 1 x to the 15th plus 15 times 2, which is 30 x to the 14th, plus, the last one's 15 factorial over 13 factorial 2 factorial, which is 15 times 14 over 2, which is essentially 15 times 7, or 105, times 4, 420x to the 13th. There's the first 3 terms of that binomial expansion. Question D says find the 5th term. All right, so we're going to do 14 choose, now starting from 0, 0, 1, 2, 3, 4, so 14 choose 4. It's always going to be one less than which term you're looking for, by the way. 2x to a power, and then negative 3 to a power. The easiest way to do this is that this term exponent should match this. So that's 4, and the other exponent should be 14 minus 4, which is 10. All right, so we have 14 choose 4. I'm going to use my calculator for that. 14 choose 4, which is 1001. 2 to the 10th is 1024, so times 1024x to the 10th. And then 3 to the 4th is 81. So times 1001 times 81. So my term would be 83026944 x to the 10th. All right, find the x to the 6th coefficient. All right, so if it's x to the 6th, let's just kind of think our way through this here. The first term would be x to the 8th, then x to the 7th, then x to the 6th. So we're looking for the 3rd term. Looking for the 3x to the 6th power, which means the 1 would be the 2nd power. So that would be 8 choose 2. All right, so 8 choose 2. Again, I'm just using my calculator to save some time here.
Introducing the new Mirage.
Gotta love the ads. Would be 28 3 to the 6th would be 729. X to the 6th times 1. So my answer is 20,412 x to the 6th. So the answer is just 20,412. All right, F on the middle term. So if it's the 10th power, that means there's 11 terms. So we're looking for the term that's in the middle here. That's going to be 10 choose 5. So it's going to be 10 choose 5. That's in the middle from 0 to 10. And then we're going to have 7x to some power and negative 2 to some power. And remember, these are always going to match. So it'd be the 5th power there, and then 10 minus 5 for the 5th power there. All right, so 10 choose 5. Is 252. 7 to the 5th is 16,807 x to the 5th. And negative 2 to the 5th is negative 32. All right, so this middle term is negative 135, 531, 648 x to the 5th. Okay, so in the next one, let's get rid of the calculator here. So you might be thinking, how do we use the binomial theorem to expand a trinomial? Well, the first trick is to assign a new variable to turn this in from a trinomial into a binomial. So let's just make up another letter here. Let's call this whole thing 4x minus 1. We'll let u equal 4x minus 1. So now my problem becomes x squared plus u cubed. Okay? So now my coefficients are 1, 3, 3, 1 from the Pascal's triangle earlier today, or you can use binomial theorem, which is actually what it tells us to do. But I know that 3 choose 0 is 1. This is 3 choose 0, right? 3 choose 1 is 3. 3 choose 2 is 3. And 3 choose 3 is 3 is 1. So I already have that down. All right, and then I have x squared to the third, x squared to the second, x squared to the first, and x squared to the 0. Okay? And then I have u to the 0, u to the first, u to the second, u to the third. So now I can write this as x to the 6th plus 3x to the 4th u plus 3x squared u squared plus u cubed. Replacing u with what we already had it as earlier today, so I have x to the 6th plus 3x to the 4th times 4x minus 1 plus 3x squared times 4x minus 1 squared plus 4x minus 1 cubed. All right, and then if we wanted to keep going, which we will a little bit more here, but we're not going to go all the way to the end, we can use our binomial expansions to expand these two as well, right? So we have x to the 6th plus, if I distribute the 3x to the 4th, that'd be 12x to the 5th minus 3x to the 4th plus 3x squared. I know this is going to be 16x squared minus 8x plus 1 plus, okay, so now my binomial expansion again is 1, 3, 3, 1 times 4x to the third times 4x squared times negative 1 times 4x times negative 1 squared times 4x to the 0 times negative 1 cubed. All right, and then we can simplify that out from there as well. All right, but for this, we'll just stop there for now. That's how you would use the binomial theorem to expand a trinomial. And that's it for the binomial theorem today. I hope you enjoyed today's lesson, and we'll see you again soon.